Okay, so this is balancing chemical equations number 2, and it is problem number 2. So this is a combustion problem. Later on next week, we're going to learn the types of chemical reactions. We're going to classify them. You don't have to know that today, but just to start introducing some of the vocabulary, this is a combustion reaction. It's a hydrocarbon plus an oxygen making a CO2 in a water. So it's a combustion reaction. And the reason I just even bring this up is because the method I'm going to show you for balancing here is going to be the most helpful if you balance it in this way. Excuse me. So we're going to balance it when we have a hydrocarbon. So not even thinking about the word combustion. If you have something that starts with a carbon, I want you to watch and do it in this way for balancing. So C, H, and O. Similar to yesterday, we have 8 C's, 18 H's, and 2 O's on the left. 8, 18, and 2. We have 1, 2, and 3 on the right. Now, we got a 1 and 2. Now, the 3 comes from, there's 2 here plus this one, which is 3. So 1, 2, and 3 on the right. Questions about any of my numbers? Questions about my setup or any of my numbers at this moment? Please do not hesitate to ask.
So you added the 1 and 2?
Correct. You're going to add them when they're on the same side of the equation. Okay, so, excuse me, my goodness. Okay, we're going to put carbon first, so we're going to put an 8 in front of CO2, because 8 times 1 makes carbon go to 8. Now, I realize that 8 changes oxygen, but we're going to leave oxygen in a combustion alone to dead last, okay? So then we're going to do hydrogen next, and we're going to leave water as H2O. Yesterday, we talked about making water HOH. You should only make water HOH to help when you're balancing with polys. So I should only make water HOH if there's an OH on the other side, and there isn't an OH on the other side. So I want to leave water as H2O. So I need to get 18 water, so I'm going to put a 9 here, because 9 times 2 is 18. So 8 times 1 is 8 for carbon, carbons are balanced. 9 times 2 is 18, hydrogens are balanced. Now that you have carbon and hydrogen balanced, then I want you to go back in and look at your oxygen. So I'm thinking about the oxygen from here. 8 times 2, look at the screen if you're not, 8 times 2. 8 times 2 is 16, everybody see that? 8 times 2 plus 9 times 1, 9 times 1, because there's a 1 here, is 9. So that means I need 25 oxygens now, based on what I did to my carbons and hydrogens. I need 25. Questions about where I get any of the numbers or anything on the screen? Okay, I need to, get 25 on the other side, right? So I recognize that whatever I put in front of O2, I have to multiply by a 2 to do it, because there's O2 always, right? So I need to think about what's half of 25. Half of 25 is 12.5, and you can write it as a decimal or a fraction. You can do 12.5 or 12.5. I hate fractions, so I don't write them. I like decimals better. It's the world I live in. All right. Technically, then, we have 25 and 25 oxygens, but first-year chemists, we're not leaving decimals or fractions. When you get to more advanced chemistry, you will. Instead, we're going to multiply all the coefficients. Coefficients are the numbers in front by a 2. We're going to multiply all the coefficients by a 2. So remember, there's a 1 here. We don't write 1s, but there is a 1 there. So this becomes 2. This becomes 25. This becomes 16. And this becomes 18. We will multiply all of the coefficients by a 2. So 2, 25, 16, 18. All right, and now we're going to go through and we are going to double check our math. So now I recheck my math. I see that 2 times 8 gives me 6, my brain today, oh goodness, 16 carbons. And then on the other side, 16 times 1 gives me 16 carbons. For hydrogen, 18 times 2 is 36. Or 2 times 18 is 36. And then on the left-hand side, let me try that again. On the left, it's 2 times 18, which is 36. On the right, it's 18 times 2, which is 36. And then oxygens, we've got 25 times 2 on the left, which is 50. And on the right, we got 16 times 2, which is 32. and 18 times 1, which is 18. So 32 plus 18 gets me to 50, and we now know it's balanced as a 2, 25, 16, 18. 2, 25, 16, 18. Questions about number 2? Okay, so now we're going to go on to number, let me get my list out because I don't remember. Started working on other things during lunch. Now we're going to go out to number 6. So go look with me at number 6. Let's practice another one together. Okay, we recognize we're going to do this method as the C, H, and O because it starts with a carbon. So 7, 14, and 0. Oh, let's try that again. 2, and 1, 2, and 3. 7, 14, and 2, 1, 2, and 3. Questions about my list? Okay, so now we're going to put a 7 in front of CO2 to get carbons to 7. 7 times 1. We're going to put 7 in front of hydrogen on the right. 7 times 2 makes hydrogens both go to 14. And now I'm going to deal with oxygen. I don't want to deal with oxygen until the end. Look at the first piece here, 7 times 2, right? So that oxygen is 14. And then 7 times 1, right, from water, that gets me 21 oxygens. I told you guys oxygen is difficult. Doesn't like to play nicely with others, so to speak. Okay, so we got 21 on the right. I need to get 21 on the left. So I say, well, what times 2 gets me to 21? How about 10.5? 10.5 will get me to 21. If you don't know that, take your number you get on this side, divide by 2, right? All right, so we're going to multiply. I can't leave the 10.5 or the 10.5. Multiply all my coefficients through by 2. Before I do that, any questions about any of the numbers or any of the stuff on the screen? Multiply through by 2. This was a 1, even though we don't write it, so it becomes 2, 21, 14, and 14. Now, you can use pencil and erase, or if you want to scratch out, you can scratch out like I'm doing. Just make sure I can very quickly see what your correct answers are. Questions about 6? Questions about 6? Okay, I would like you to go try 7 and 9. I'm going to give you about 5 minutes, so about 10, about 12, 15, 12, 16, we'll go over 7 and 9. Go try 7 and 9. Reach out if you need help. You may not hear me, but I'm back here. I'm just doing other things. Reach out, go do 7 through 9, and reach out in about 5 or 6 minutes. Okay, number 7. Number 7, let me flip back to my answer key because then I don't have to do it in my head really quick. Number 7 should be 2, 13, 8, 10. 2, 13, 8, 10. Anybody need to see it? Please let me know. Don't hide. Don't be embarrassed to ask. This is your learning time. If you need to see it, I'll do it.
Yes, please.
Okay. All right, so we're going to say C, H, and O, 4, 10, and 2, 1, 2, and 3. Alex, I think that was you. Anybody else? Anybody not understand where I get my numbers? Tell me if you don't understand where my numbers come from. Okay. Put a 4 in front of here to get my carbons balanced. I need 10 hydrogens, so what do I have to put in front of 5? So that gets me 10 hydrogens. Questions about the 4 and the 5 placement, anyone? Okay, so now this oxygen is 8. This oxygen is 5. So there's 13. 4 times 2 is 8. 5 times 1 is 5. So I need 13 over here, so I'm going to think about 6.5 being placed there. 6.5 now balances because 6.5 is 13. 6.5 times 2. Can't leave it in there. This becomes a 2, a 13, an 8, and a 10. Questions for that? Clarity on that one. Okay. No questions?
I had a question.
Go ahead, sorry.
Okay, I was wondering as to why we multiply by 2 again.
Because first year chemistry, we're not going to allow you to put fractions or decimals in.
Okay.
Now, when we get to higher level chemistry, you'll see fractions like 1/3 and things like that. But first year chemistry, we pretend like you can't do that, even though that's why I say that, because I don't want you to get to another year chemistry and be like, she was a liar. But yeah, you can use fractions later on when you get to upper level chemistry. But for our course, we're going to say no fraction, no decimal.
Okay. Thank you.
You're welcome. Thanks for the question. Anybody else? Okay, number 9 is 1644. 1644. Does anybody need to see it? It's okay if you do. You just need to tell me you do.
I'd like to see that one, please.
Okay. I don't mind doing them. I just don't want to do them if everybody's got it. You know, I want to respect your guys' time. Okay, so 482, 123. Questions about my numbers? Okay, 4 in front of carbon gives me a 4. I need 8 hydrogen, so I got to put a 4 over there too. That gives me a 4. Oh, pardon me, an 8. 4 times 1 for carbon is 4. 4 times 2 for hydrogen is 8. Now I'm going to evaluate my oxygens. I have 8 plus 4. Something doesn't feel right. Yeah, never mind. I can't do math in my head. I'm really struggling with the simple math today, y'all. I apologize. 8 plus 4 is 12. So I got to put a 6 over here to get to 12, and then there's no decimal or fraction, so no need to multiply through. Questions about 9? Clarity needed on that one. I'd like to do number 10 next if there's no questions on 9. 10 is the last piece of balancing that we have to do that is just pure balancing. All right, number 10. So we're going to do C, H, and O. 6, 14, and 3 this time. Notice there's 1 here and there's 2 here. When they're on the same side, we have to add them. Look at the screen if you didn't see this. 1O and 2O. 1O and 2O, that's how I get my 3. That's the similar process we did on the other side, right? Where we have 1, 2, and 3. What this is still a hydrocarbon, a carbon plus a hydrogen, but it is a hydrocarbon, and you can have other things with hydrocarbons. This could be an acid or a carboxylic acid or an ether or an ester or an alcohol, some kind of organic, structure. All right, we're going to start with carbon. We're going to put a 6 here. That gets my carbons to 6. 6 times 1. Going to put a 7 here because I need 14 hydrogens. 7 times 2, I had 14 on the other side. I recognize I need 14 on the right. 7 times 2 is 14. Now, carbon looks fantastic, and so does oxygen. Now we have to deal with, carbon looks fantastic, and so does hydrogen. Now we need to look at oxygen. We have 12 plus 7, which is 19. So I need a total of 19 oxygens on both sides to balance this. So I'm going to think about that because I got this guy in the way. And you should see, please look up at the screen if you're not, you should see that if I put anything right here, right, if I put anything right here, it's going to affect everything on that side. So I want to avoid that if I can. So what you need to think about is you need 19 total, so I'm going to write that over here. Take away however many is attached to this first piece. In this case, there's 1. That gets me to 18. I need 18 more on that side. So if this was 06, I would have subtracted 6 from my total of 19, right? So however many oxygens I have, that's how many I subtract. So I need 18 more on the left side. So if I put a 9 here, because 9 times 2 is 18, it is now balanced. Questions about 10?
Where did the 12 come from?
Where did the 12 come from? Oh, right here. Hold on, my pen. 6 times 2 for oxygen, right? You see it?
Yeah,
All right, any other questions?
so why are we allowed to just subtract that oxygen?
We're subtracting it, but we're not like disregarding it. We're just taking to account it in our count. So we're taking it out of our count so that we don't have to worry about putting something in front. So we're not subtracting it. We are physically subtracting it, but really we're just accounting for it early, or putting it in our count early, right? Did that help? Was that Jesse? Did that help? I don't know who that was. Okay. All right, so you're going to try now 12 and, hold on, 12 and 16. Please go try 12 and 16. Okay, so for number 12, C, H, and O, 4, 10, and 1. I'm sorry, not 1, 3. Goodness gracious, because it's 1 plus 2 is 3. 1, 2, and 3. Questions about my numbers. Put a 4 here to get carbons balanced. Put a 5 to get 10 hydrogens. Okay, and then we got to take care of our oxygen. So here we have 8, and from here we have 5. And 4 times 2 is 8. 4 times 2 for oxygen, 5 times 1 is 5. That is 13. So I need to have 13 on this side. Take away this 1, because I want to account for it, or take it into account early so that I don't mess up the other side, because if I put anything here I recognize I'd mess up that side. So I need 12 more, so I can put a 6 here, and it's balanced with a 1, 6, 4, 5. Questions of clarity needed for that? Questions of clarity needed for that? All right, 16 then is 2, 19, 14, 12. I'm just assuming that someone's going to need that, so I'm going to go over it. 2, 19, 14, 12. Let's go through that one. So we have, let me get my pen working again. C, H, and O, 7, 12, and 3. 1, 2, and 3. So get carbons balanced. Let me give you a moment to get those numbers. 7, 12, and 3. 1, 2, and 3. All right, for carbon, I'm going to put a 7 here. That gets me 7 carbons on both sides. I need 12 hydrogen, so I'm going to put a 6 here. That gets me to 12. Now I'm going to look at oxygen. I have 14 plus 6, so I need 20. I have 20 over here total, but I have to account or take into account first that I need to get rid of that, however many are attached to my hydrocarbon in the front. So I need 19 more. So I'm going to put 9.5 or 9.5 there temporarily. That technically balances it. Questions about any of that so far? Then I'm going to multiply. Oh, go ahead. Sorry.
0.5. Why do we write that?
I need 19 more on this side, right?
Yes.
And so I got to say 19 divided by 2, because whatever I put in front of this O2 is going to have to be multiplied by 2, right?
Okay.
So 19.5 times 2, or 19. 9.5 times 2 is 18, or 19. My goodness. Let me try that again. 9.5 times 2 is 19, yes?
Yes.
Okay. Does that make sense, though, or why or no?
I'm guessing it's odd numbers that you do points with.
Yes. Well, yes, odd numbers that you'd have to put in front of oxygen, yes. Okay, in front of O2, I should say, not oxygen in front of O2. Okay, now we're going to multiply through by 2, so that's 2, 19, 14, and 12. Questions about that?